In this lesson, we'll be looking at how to find the length of a line segment and the midpoint between 2 points. So as you can see here, I've got my line segment and I've got two pairs of coordinates, -3, 8, and then down here 4 and -1. Now what I'm going to call these is, I'm going to call this point x1, this point y1, this point x2, and this point y2. Now we could have done that the other way around. It doesn't matter which set of coordinates you have as your first set and which set you have as your second set. Let's look at finding the distance first. If we want to find the distance or the length of this line segment, we can use the distance formula, which is d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. So that's the rule for finding the distance or the length of a line segment when you're given 2 points. And it's as simple as substituting in the values in our coordinates. So for this particular line segment, we'll get d equals the square root of our x2 value is 4, our x1 value is -3, so 4 minus -3 all squared, plus y2, which is -1, minus our y1 value, which is 8 all squared. So all I've done there is substitute my values in, and we can keep going with that. So d equals 4 minus -3 is 4 plus 3, which will give us 7 squared, plus -1 minus 8 is -9. So in here we'll get -9 squared. If we keep going with this, we'll get d equals the square root of 49. 7 squared is 49. Minus 9 squared is 81. So plus 81. And our final answer is the square root of 49 plus 81 is 130. Now this rule for finding the distance, it actually comes from Pythagoras. So if we were to draw a little dashed line down and across, we've created a right angled triangle. And let's call this hypotenuse D, we'll call this side A, and we'll call this side B. Now using Pythagoras, we know that A squared plus B squared equals D squared. And we can rearrange that to solve for D. D equals the square root of A squared plus B squared. Now, this distance of A is our x2 value minus our x1 value. So this here is essentially the A. Our B value is the difference between the two y coordinates. So that's this y2 minus y1. So that's where this distance formula is derived from. Now, if we were to find the midpoint of this line segment, the midpoint of a line segment is just found by taking the average of the two x coordinates and the average of the two y coordinates. So the rule for finding the midpoint is m equals x1 plus x2 over 2, so the average of the two x coordinates, y1 plus y2 2 over 2. So remember, the midpoint is actually a set of coordinates. So all we've done there is take the average of the two coordinates. So for us, our x1 value is minus 3, so we'll get m equals minus 3. Our x2 is 4 over 2. Our y1 is 8. Our y2 is minus 1. Take the average of that. So if we keep going with this, we get m equals minus 3 plus 4 is 1 over 2. 8 plus minus 1 is 7, so that's 7 over 2. So our midpoint is the coordinates a half and then 7 over 2. Now let's have a look at a question that involves a slight variation of our distance rule. So find A the distance between 2A and 4, 9 is root 5. So we know D equals the square root of x2 minus x1 all squared plus y2 minus y1 all squared. We know our D value. We know our x1. Let's call this x1, y1, x2, y2. We know our D is root 5. The distance is root 5. So root 5 equals, let's substitute our points in. x2 is 4. x1 is 2 minus 2 all squared plus our y2 is 9 and our y1 is a. So that's what we're trying to find, the a value there. That looks a little bit like a 9 as well. So if we can square both sides of this equation to actually remove the equal sign, but why don't we try and tidy up this right hand side first. So we've got root 5 equals square root of 4 minus 2 is 2, 2 squared is 4, plus 9 minus a all squared. As I said, we can tidy this up a little bit. We can get rid of the square roots on both sides by squaring both sides. So if we square both sides, we'll get 5 equals 4 plus 9 minus a all squared. Let's rearrange this, bring the 4 over to the other side. So we'll get 1 equals 9 minus a squared. If we square root both sides, we'll get plus or minus 1. If we square root 1, we'll get plus or minus 1 equals 9 minus a. So therefore a equals 9 plus or minus 1. So therefore a equals 9 plus 1 is 10, or a equals 8. So there's actually two solutions for the value of a. it could take two possible values for this question to work out and for the distance of that line segment to be root 5. So hopefully that's been helpful for you.